we govern through Director General. He is also a secretary of DSIR, Department of Scientific and Industrial Research. In fact, the CSIR has established before independence and through Central Legislative Assembly under the Registration of Society Act of 1860. So it's an autonomous, completely funded by the government organization, government. We also entertain the projects. We take projects from the industry and the private organizations and government organizations, which are suitable for the societal benefits. And also, we offer projects to the faculty, particularly the university faculty, and also, we also sponsored some of the workshops to the schools if they want to conduct a workshop to improve their knowledge or to get the familiarity in a given technology or given scientific topic. If they conduct a workshop or seminar or conference, we also partially sponsored for those workshops and seminars and conferences. These are all various aspects. And also, personally, if you see, we do award JRF and SRF fellowships who are interested to do PhD, interested to do R&D in their own interesting field. That's why I say CSIR is a beautiful organization where you can choose the areas which you like, and you can choose the way you want to conduct the R&D, but we fund for them if you are really good in the subject. So this is our organization. Under the CSIR, like MTech, what present organizing institute, and also NAL, NPL, CSIO, Siri Bilani, and many organizations, they are there in each and every field. One of the beautiful feature in CSIR is it takes every field. Biological Research Institute is there, Chemical Research Institute is there, Mechanical Engineering Research Institute is there, Civil Engineering Civil Engineering Research Institute is there. Similarly, Aerospace Research Institute is also there. So you name it, any field of the existing in general, 38 laboratories, almost 38 different fields you can do a research. So this is for the entire country. It's not for any other organization like DRDO. They talk about only defense applications. ISRO, they talk about only in satellite and rocket applications. And ICR, they talk about only agriculture. But CSIR takes all of them. So that's the greatness of the CSIR, and it has been contributing in a great level to improve the technology in the country. So we have been improving technology through the CSIR labs. In that matter, if you see, many of the DRDO labs are using our technology. ISRO even have using our technology, our sensors, used in Chandrayaan experiment also. So this way, we are not only contributing to the country R&D organizations, we are also contributing, we are also empowering the manpower to improve their technology in the as per their requirement and also as per the industry requirement. So we are happy to announce we are contributing in a good manner and better than any organization in the country. Okay, with this, I would like to go what we are having in this talk. What is the outline of this talk? First, I would like to introduce the IoT. Then I would like to talk about the various applications. क्योंकि एप्लीकेशन के बिना अगर आप जानते भी हैं टेक्नोलॉजिकली, आपको काफी प्रॉब्लम्स आएंगे इंप्लीमेंट करने में. अगर आपको एप्लीकेशन समझ में आता है, डिपेंडिंग अपॉन योर नीड, व्हाट काइंड ऑफ एप्लीकेशन यू कैन implement, that kind of application you can take it and उसको लेके समझ के डिजाइन करके और उसको इंप्लीमेंट करने के लिए कोशिश करेंगे. उसके अंदर हम बात करेंगे हाउ टू डू अ सिस्टम डिजाइन, बिल्डिंग ब्लॉक्स ऑफ IoT सिस्टम. देन स्लाइटली दो आप लोग सब लोग स्कूल में हैं मुझे पता है, फिर भी मुझे ऐसा लगता है कि थोड़ा बहुत डीप नॉलेज भी चाहिए. So I will talk about the IoT architecture model basically, क्योंकि this is one of the technology where starting from 8th class to ending from PhD problem, up to that level you can contribute. उसके लिए आपको थोड़ा बहुत टेक्नोलॉजी डीप अंडरस्टैंडिंग इज रिक्वायर्ड. इसलिए हम क्या करेंगे, I'll try to explain the IoT architecture model like a computer architecture model. So if somebody did computer science and engineering or MCA or something BCA or BSc computers, they must have this model, but still, however, I'll try to simplify during my explanation. You can also ask me the questions. Since I am not able to see your faces, if I see your face, I could have modified my talk. Since I cannot see your faces, what I'll do, please listen carefully. And if you have any doubt, write down on the page. At the end of the session, we will try to ask you the doubts. During that time, हम बात करेंगे थोड़ा सा लो लेवल पे भी जाके, आपको जितना तक समझ में आता है उतना लो लेवल तक चल के हम बात करेंगे. फिर भी आपको डिलीवरी टाइम पे थोड़ा बहुत कंसंट्रेशन रिक्वायर्ड, कंसंट्रेशन से सुनना पड़ेगा तभी कुछ समझ में आएगा, नहीं तो थोड़ा बहुत ऊपर ऊपर चले जाएगा, दिमाग में कुछ रहेगा और कुछ नहीं रहेगा और क्या रहा कुछ समझ में नहीं आएगा. इसलिए थोड़ा सा उसको कंसंट्रेट देना पड़ेगा. जैसे आप मैथमेटिक्स बच्चों को पढ़ाते हैं तो आप फेस देख के बोल पाएंगे कि ये बच्चे को समझ में आया कि नहीं है, लेकिन यहाँ पर तो फेस देखने का मौका ही नहीं है. Maybe for the last 1.5 years you might have also faced the same problem, and whatever you are trying to give your best effort might have not reached because not all the students were attentive. Now I would like to request all of you, try to focus attentively, and if you don't know in between also, I cannot see the message, so what you can do, you can make one coordinator. If any question is there, let him read the question. You put your question in the message chat box, and let him read and ask me in between also, so that yes. आपको बहुत ज्यादा माने अंदर जाके या नीचे जाके मैं बता पाऊंगा.
Sir, we have this facility. I invite questions from the attendees in the chat, and I will read it for you, sir, so that you can address this.
Yes. Okay. Acha, Shekhar, slightly be louder.
Okay, fine, sir. So I will read the comments as and when they appear. And
correct. Okay. Then after the architecture model, what we can do, IoT and its related technologies and terminologies. काफी बार क्या होता है यार, मैं बिग डेटा पे काम कर रहा हूँ यार, मैं IoT पे काम कर रहा हूँ, मैं रेस्पबेरी पाई पे काम कर रहा हूँ, अच्छा मैं एम्बेडेड सिस्टम मल्टी प्रोसेसर पे काम कर रहा हूँ. सो ये जो टर्मिनोलॉजीज है, आपको जैसे लगता है कि यार मैं तो कुछ किया है तो नहीं है, अच्छा ही इज टॉकिंग वेरी न्यू टेक्नोलॉजी. सो नॉट टू गेट इनटू दैट मोड, मुझे लगता है कि आपको ये टर्मिनोलॉजी समझाऊं तो आप काफी कुछ बच्चों को भी समझा देंगे, और आप खुद भी समझने के बाद आप खुद भी इंटरेस्ट लेंगे थोड़ा बहुत इंप्लीमेंट करने के लिए. देखिए, I know about Atal Bihari Vajpayee labs, and also the encouragement that the government of India is doing. All these things are only fruitful. हम लोगों को तभी काम आएगा जब हम उसको समझ के, जो सोच गवर्नमेंट सोच के बनाया है उस सोच में हम अगर उसको सोच को लेके हम करेंगे तो तभी कुछ होगा. नहीं तो गवर्नमेंट हैज बीन डूइंग दिस स्किल डेवलपमेंट प्रोग्राम एंड जिज्ञासा प्रोग्राम, एंड हाउ मच वी हैव इम्प्रूव्ड, दैट हैज टू बी शोन विजिबली. तो हम समझने के लिए कोशिश करेंगे. अगर ये टेक्नोलॉजी आपको समझ में आया है, अगर बच्चों को समझाएंगे तो बच्चे थोड़ा बहुत और भी क्यूरियोसिटी लेके वो कुछ करने के लिए कोशिश करेंगे. फर्स्ट यू आर द फर्स्ट स्टेप फॉर द स्टूडेंट्स, एंड नेक्स्ट इंटरेस्ट ऑफ द स्टूडेंट्स, देन थर्ड इज द एनवायरनमेंट. If you are interested, you can create a curiosity in the students. If you are interested, you can create a environment for the students. That is how it's a chain of the link. Government thinks, it try to make some schemes and try to put these schemes to on particular people, and the people try to avail, and then the kind of benefit that is required for the people should come through the technology. अगर ऐसा हम ये साइकिल को बनाएंगे तभी कुछ हम लोग हैप्पीली विल लिव इन दी कंट्री. सो उसके बाद टेक्नोलॉजीज के बाद हम बात करेंगे चैलेंजेस एंड सम इश्यूज. वो चैलेंजेस इसलिए करना पड़ेगा, भाई टेक्नोलॉजी तो मेरे को समझ में आता है और टेक्नोलॉजी तो मेरे को समझ में आ गया. अब मैं इंप्लीमेंट करने के लिए मैं ऑटोमेटिकली मैं सोचता हूँ कि मेरे को एक रास्पबेरी पाई चाहिए और बाकी मैं संभाल पाऊंगा. ठीक है, रास्पबेरी पाई अगर दे दिया तो आपको पूरा का पूरा समझ में आ जाती है, ये देखना पड़ता है. अगर आ जाती है तो इंप्लीमेंट के वक्त में क्या प्रॉब्लम आएगी वो भी देखना पड़ेगा. तो इसलिए हम समझाएंगे challenges and issues in designing the IoT system. ये थोड़ा सा नेक्स्ट टॉपिक जो है थोड़ा सा आगे है और थोड़ा सा डीपर भी है. मुझे लगता है कि आपको बोलना ही पड़ेगा, क्योंकि काफी लोग रास्पबेरी पाई को जानते हैं, आर्डिनो बोर्ड को जानते हैं, लेकिन वो तो आपका लेवल पे बहुत अच्छा है, उसमें कोई शक नहीं है. Even if you do with the Raspberry Pi and Arduino boards and Icsp Wi-Fi modules, that itself is a great contribution, no doubt. But I will also give what are the other platforms which are useful for industry or real-time implementable IoT platforms. I will try to give you so that you can see what are the difference between normal academic oriented platforms and the IoT real-time computing platforms, that the difference. After that, of course, we try to conclude. मुझे मेरे टॉक में एक आदत है, क्या है कि मैं कभी भी कंक्लूजन में आता हूं तो वो जल्दीबाजी हो जाते हैं. कारण क्या है कि बहुत ज्यादा बीच में टाइम लग जाते हैं. तो कंक्लूजन इज नेम शेक. आई ट्राई टू कंक्लूड, बट द कंक्लूजन मीन्स हाउ मच यू अंडरस्टूड. I will ask few questions. If you are interested, you can give the answer. And had it been, direct interaction, definitely I would have asked the questions. Since it's a online, maybe I may not be able to see your face, and at the same time, I cannot, I don't know many names, and I may not be able to point you through this. Hence, I'm trying to pose only few questions, and maybe you can answer yourself after the completion of the talk during the conclusion time. Am I clear?
Yeah, yes, sir. Yes, sir.
Yes, sir.
All right. So we'll talk about the introduction of the IoT. See, basically introduction of IoT का IoT है क्या है? Basically ये जो IoT जो है एक डिवाइस है. ये डिवाइस जो है उसको प्राण नहीं है, उसको लाइफ नहीं है, बट फिर भी जैसे आदमी बात करता है वैसे बात करना पड़ेगा. Any physical entity should have the kind of reaction human being is doing. The physical entity should make that kind of reaction. If you can make any physical entity by providing whatever you wish, and if it is reacting with the other physical things as well as the human beings, that is nothing but a IoT. First, we will see the formal definition. In 1991, Kevin Austin said he tried to define a computer network as a IoT with the customized embedded system connectivity like a computer system. But after the many years evolving, now what is the IoT is all about information visibility. You have to make information visibility. जो भी डेटा है वो डेटा लोगों के पास पहुंचाना है. अच्छा, कैसे? ये एक प्रोसेस है. देन मुझे जो इंफॉर्मेशन चाहिए वो ही चाहिए. मैं जिसको भेजना चाहता हूं उसी को भेजना चाहिए. बीच में मैं शेखर को भेजना चाहता हूं लेकिन आप सब लोग भी देख रहे हैं, वो नहीं होना चाहिए. दैट इज नथिंग बट IoT. IoT is a device which will make information visibility without having any problem in maintaining privacy, security, confidentiality. These three things are important: privacy, security, and confidentiality. That means it's a network of things with the device identification and some intelligence and sensing and acting capabilities, connecting people and things over the internet. एक बार मैं इंटरनेट को कनेक्ट करने के बाद डेटा मैं आइदर सर्वर को भेज सकता हूं या मैं क्लाउड को भेज सकता हूं या बोथ को भी भेज सकता हूं. अच्छा, किस लिए चाहिए भाई मेरे को डेटा? डेटा किस लिए चाहिए? मुझे तो पहले बात डेटा लेके क्या करूं, और कोई भी फिजिकल सिस्टम आदमी जैसे कैसे बनेगा, बात करेगा कैसे? और इन any physical system, how it will make information visibility? You just think in this line. अच्छा, अभी हम लोग एक एग्जांपल लेंगे. ये कौन सा एग्जांपल है? You take your chair. You take auditorium, or you take any function hall. Now, let us say your function hall has been working for the many years, and there are certain chairs. Chairs, some of them are good and some of them are not good. Even though you took a repair and everything, आपने रिपेयर भी करवाया, सब कुछ करवाया, फिर भी बीच बीच में टूटते रहता है चेयर्स. Agreed or not? I think I did not get any information from anybody.
No, sir, we have replies in the chat. People are agreeing on your point. They are saying yes.
So अगर मान लीजिए आप एक फंक्शन कंडक्ट कर रहा है, फंक्शन रोज तो कंडक्ट नहीं कर रहे हैं, कभी कभी फंक्शन कंडक्ट कर रहे हैं, या आपको ये पता होना चाहिए कि सारे चेयर्स अच्छा है कि नहीं है. सारे चेयर्स अच्छा हो तो ठीक है. मान लो आपने सब चेक करवाया, सब कुछ ठीक हो गया, लेकिन फिर भी एक आधा टूटा पड़ा हुआ है, वो मिस हो गया. ये तो मैनुअल मिस्टेक हो जाएगी. अगर मान लीजिए आपने IoT टेक्नोलॉजी उस ऑडिटोरियम को अगर अप्लाई कर दी है, तो आपको ये प्रॉब्लम नहीं आएगा. कैसे, मैं बता देता हूं. मान लीजिए अगर चेयर पे आप बैठने से पहले अगर चेयर आपसे बात करती है, लुक आई एम डर्टी, फर्स्ट क्लीन इट एंड देन सिट. हाउ लवली यू लाइक इट. अगर चेयर, इफ इट इज स्पीकिंग विथ यू, लुक आई एम डर्टी, प्लीज फर्स्ट क्लीन मी एंड देन सिट. If it says, and your new clothes and brought for wear for function, all those things will be said. It won't be dirty. The other one, if says, look, I am weak. Look, I am weak. I may break at any point of time. So please don't sit on me. Please don't sit on me. If a chair speaks with you, then it is a beautiful, and you will also love it. And also the same chair is suggesting, look, in first row, second chair is empty. You please go there and sit. If somebody is trying to sit, in the corner, in the functions, many of the people they want to try to stand in the corners or side of the way, even though the chairs are available. Even though chairs are available. So if any chair automatically suggests, hey, I am empty, please come here. भाई मैं काली हूं, आ जाओ मेरे अंदर बैठाओ. अगर कोई बोलता है, चेयर अगर ऐसा बोलती है, so how good this is. So you think on that level. Now we assume in the auditorium, chair speaks in three ways. One is I am dirty, second one is I am weak, third one is I am empty, please come and occupy me. Let us say we assume these three things we should provide in the auditorium. Then think of how to do it. Think of how to do it. First thing, whenever we wanted to say I am dirty, then we need to use see, it's not a human being, so that it can see. It's not a human being, so that it can see. So we need to have a sensing aspect. We need to have sensing aspect. That means the chair is dirty or clean. So two sensors are required. To sense any physical parameter, we require a sensor. The sensor, what sensor is required? That is, depending upon the function. To sense the dirtiness, we have to use dirty sensing sensors or image processing, camera basically. With the camera, I can take the image and see whether this is good or bad by doing the image processing analysis. Or sensors, after having certain dirtiness, it will send some threshold voltage, and based on that voltage, whether it is just a small dirty or many small particles are there just invisible, or more dirty is there, so that the cleaner should come, or no dirty, so that no cleaning is required. So that is basically sensors output, which will sense the dirtiness with the different thresholds, which will give an indication. Okay, sensing over, chair knows that it is dirty, then it should speak to you. How it will speak to you? There are two methods. Any object can speak to you or communicating to you is text-to-speech synthesizer first the sensing value, let us say threshold value of dirty, medium level dirty. So it will display the information based on the sensor value. Medium level dirtiness is there, and that text value can be given to the text-to-speech synthesizer. Now Google, is also speaking for you. In many readers are available. They read the file and you can listen to them. Similar kind of thing we can also incorporate in the chair. So you read a device which will be having sensing, which will also do processing. That is whether this is below threshold or above threshold, and also it will try to display the data, so that you required LCD display or any other display, and that data, if you want to send it to the like a speech, then you can make it a text-to-speech synthesizer, and it speaks well. Then after that, it can be passed to through the networking to remote places also. So this is how you can make a simple chair able to speak with human beings as well as with other chairs using IoT technology. Okay, I believe you understood, and if you don't understand what I spoke, you can also raise, or you can make any questions. So assuming I did not receive any questions, I am going through the Internet of Things, where we can apply what kind of applications. Literally, if you speak, every application you can apply the IoT. And what is the facility, or what kind of features it will provide, any time, any context. Any time, any context kind of applications also you can provide on any data, and any data can be connected to the internet. Any network you can use, not only TCP/IP, you can use cell phone, you can use Wi-Fi, you can use even the Bluetooth. You can also use RFID. You can also use RFID. Any service and any business. See, as I told you, if I collect a temperature or dirty data and given to you, it's a value. You don't know 3.4 or 4.5, like that, some value will come. That value has to be converted into the service. That value should be converted into the service. What is that service? For example, you take the same theater. When people are more and outside temperature is more, you need more AC. So depending upon the temperature, you can adjust the AC capacity also. When people are less and outside temperature is low, then automatically also you can switch off some of the ACs and you can do that. Don't ask me, already ACs are there in the market to take care of it. But I can literally switch on and switch off the ACs, not the adjustment. So that the minute power also can be saved using IoT technology. So whatever I told, whatever I spoke so far, basically the IoT, or some people they call it Internet of Everything, has 4 components. One is the people, process, data, and things. Not required, not only people. If you take fully autonomous factories, they need to talk not only the people and also to the people of objects. That means the smart objects who can able to listen, who can able to speak. That means the speaking chair, the group of chairs can speak and arrange alternately to them. So connectivity is required, and then converting data into intelligence to make the better decisions. Raw data may not be useful, so if you can convert into the service, like I am dirty, you need not worry about the sensor output. But if it is saying I am dirty, people can clean it. So this is the service. And if it says I am weak, and that is the service. If Jay says I am broken, that is the service. So you need not worry how the sensor is, collecting the data, what kind of thing. But that is the service to the customer. But whereas for the designer, he needs to think how to provide these services by sensing the different physical scenarios, physical parameters, and then send it to the people. The another one is the process, basically delivering the right information to the right person. It's like, मैं तो काफी लोगों को भेजना चाहता हूँ information, लेकिन 10 लोग हैं, पूरा स्कूल नहीं है, पूरा क्लास नहीं है, सिर्फ क्लास में 10 लोगों को भेजना चाहता हूँ. So I have to have a basically multi-cast facility. So when we talk about casting, see, one is the broadcasting, everybody listens. Multicasting, from one to many people will listen, and point to point, only one to one. So unicasting. So these are all the various various communication techniques for communicating from one person to the another person. So the next one is things, basically physical things. Physical things means it can be chair, it can be table, it can be refrigerator, it can be RO, it can be scooter, it can be car, it can be flight. So anything can be, we can connect a smart device to that object and then make it in connectivity to the internet. Then automatically the things will become IoT. Finally, what I can say is IoT enables physical objects to feel Feel means sensitivity. Sensors are required. Hear. Hearing means it is able to understand our language. It is able to understand our language. That means it required a microphone. It required a text reader. It required, try to able to, understand what others are saying. So that is through microphone, through text, through image. So we can provide that. It should be able to see. Obviously, camera is required. Through the camera, that seeing feature can be provided. It should be smell. Once again, sensors, gases sensors. Gas sensors can be used for various tastes, bad smell, good smell, and aromas levels. Those things we can provide through the various combination of these gas sensors, and then think. It does the processing. Thinking processing is mainly provided through the microprocessor or computing system. In your language, you can say Arduino board, or in your Arduino processor, or Raspberry Pi 3 processor, and then it will interact smartly. How it will interact smartly? Through the display, through the speaking, through the action, through the answer to your question. So if you can provide all these features to any physical object, and if you allow that object to communicate not only local and also remotely with decision making power, then that particular object will become IoT. Then that particular object will become IoT. Am I clear? Am I clear?
Yes, sir, you are. But sir, may I request you to please leave your.
Okay. So we'll try to see various
Time.
definitions.
Yeah, we have time. Please,
Mostly, we'll try to make it brief in the definition. See, IEEE is one of the famous standardization organization. So what it says, IoT is nothing but a network of items, each embedded with the sensors, which are connected to the internet. So that's the basic definition they have given. Many people they have given many this thing. So already I had discussed how it works. Basically, it required communication and cooperation. It required addressability, identification, sensing and actuation, embedded information processing, localization, and user interfaces. So now slightly I'm going into the deeper into technologies. So communication required basically interfacing and communication, TCP/IP, understanding of TCP/IP, understanding of wireless protocols, and understanding of cell, how to interface with our system. Addressability is, basically we need to provide how to address, how to identify the device in this manner. Then sensing and actuation already I discussed. So what is the localization? Localization means even though we provide complete sensors, so the sensors data vary from place to place. So whether this place is applicable to the entire aspect or only for the local aspect. So that aspect we need to do in the algorithm so that we can make it. Ultimately, we can make a IoT device. What is that ultimate making device is? You can see here the physical parameters are captured by various sensors like temperature and humidity and maybe pressure, and depending upon our requirement, all the sensors can be connected to of the processor, and these are the sensors used for sensing these physical parameter. And then you required a signal conditioning circuit. That means whatever the data that we do take from the sensor, they may not give you the value what directly we think on. So they try to give you some value, and they are also non-linear. For example, I believe you all know the diode characteristic. So the diode is exponential in the forward biasing. So in up to cut-in voltage, it is a linear. After that, it is a exponential increase in the output current. So now for any data, we need to make them, it's a linearity. So we need to convert that non-linear aspect into the linearization by using either hardware or in the software. So that's called a signal conditioning circuit. Then we have to have processing because we need to know what is the value and what is the threshold and what kind of service I am providing. For that, we required a microprocessor. So we can use MSP 430 or ARM processor or Raspberry Pi 3 or Raspberry Pi 2, Raspberry Pi 4, any processor we can use it. Then short range signal transceiver, maybe ESP, ESP module for the Wi-Fi, and the Zigbee module for small distance, and also cell phone for the long distance, and the TCP/IP even for the longer distance. So we need long range transceiver and or the short range transceiver depending upon the value. So if you see the IoT devices, how it works in the field is you think on the cluster. This is the these are all sensing parameters and connected to one node, and these parameters are given to node, and the node is distributed in the entire environment, and now centralized node collects the data from remaining the nodes. From there, it sends to the either local server through the gateway or to the cloud platform, so that it can convert this data to services. To convert this data to services. So you assume the theater, and every chair has this kind of device, but it is having short range communication because the short range communication saves you many things economically as well as the life of the device working. So to take those advantages, we take short distance modules, communication module, and then it will sense the data, send it to the edge device, which will be having slightly longer distance compared to these clustered device. And here you can also put some kind of a little processing element, and then whatever the requirement, for example, temperature is giving every time 32, 32, 32. You don't require to send that data. What is required to send? If something is increases more than 40, then you need to send the data. So up to that point of time, you capture these samples, but you don't send outside the cluster. But once it is exceeds the data, then only you will send the that value, and based on the algorithm. For example, it will say service. Look, your sensor is, your temperature is increasing. You please switch on the AC. That's the service. Data is sensors data. Service is switch on the AC. So that kind of information is required to the user, but user does not require what is the temperature variation at the sensor actually. So you can see many devices, health monitoring also you can put watches, and you can communicate to the cloud what is the health of the person and how is health is moving. For example, diabetes. If you take a diabetes person and if diabetes is increasing, it will not allow to take any sweet. How it will loudly say your diabetes increasing, don't take sweets, don't take sweets. So that way it makes you embarrassing situation. Initially it will be slowly very low louder, and later it will make a big louder, so that the person becomes the embarrassing situation, so you will not take the sweet. So that kind of thing we can provide using the IoT facility. So we can also see the clusters are connected to cloud. Each device is also connected to the cloud, and the cluster as well as each device is also connecting to the cloud. This is how various scenarios are available for the IoT device. Okay, I think how much time I am having? Shekhar? Shekhar?
Yes, sir.
How much time I am having? 1 hour?
Sir, I missed your question, sir. What did you ask, sir?
No, how much time I am having?
Sir, it was up to 11:40, I believe, but it's okay, sir. You can take 5-10 minutes more if you have more to say, and we will have some 5 minutes for some questions, sir.
How much time I am having?
Sir, I believe you have to wrap up in like 5 minutes, and then we'll take 5 minutes for the questions, sir. So total 10 minutes we can have.
Okay. So if it is so, what I'll do, I'll try to give you some kind of what are the applications. See, all the applications you can apply IoT, including healthcare and life sciences, structural health monitoring, smart cities, building and automation. You name it. Every application you can apply the IoT. So that's the advantage for the school teachers. That's the advantage because students can also, 12th class बच्चे भी सोच सकता है कि कौन सा application कैसे apply करना है. So I'm trying to explain. These are all the various sensors depending upon the application you required. For example, if you go for retailing, then light sensor is required, pressure sensor is required, temperature sensor is required, and the chemical sensors are required. If you go for something around, environmental case, then also you require humidity, pressure, temperature, and the security case, gyroscope, accelerometer, magnetometer, and the chemical sensors, light sensors. These are all required depending upon the application. You need to select the sensors. So this is the overall view of the various applications where all possible. And see, I have mentioned the references. If anybody wants to take, you can take it more. See, healthcare and IoT technology is basically you can simply apply the village. You can apply this IoT technology to bring village people into the cities without physically they visit the actual hospital, by providing the remote access to various equipment. So here you can see the X-ray mission can also be connected to the IoT, and you take X-ray at village level and then pass it to the doctor, online and real time. Then he will absorb and then say, okay, you are good or not good. Then based on that, you can take the decision, and also you can make the related prescription. So another one is stress analysis. Nowadays, stress is increasing every day. So the stress analysis is also applicable. Since there is no time, so I am skipping. I want to discuss much more, but we can also analyze how well do I sleep. Am I sleeping, or simply going to bed and not sleeping, and tomorrow already it became 8 o'clock, but I did not sleep well. So if it is so, my health is going to deteriorate. So how to make how to improve myself to sleep well. So those things also we can do. Even using the IoT, we can control our mind. Or the other way is mind controlled object functions also we can make it. So these are all various applications for the healthcare. And this is the another efficient waste management system. You can see all the garbage cans are having your IoT device, and they are sending to the cloud and also sending to the garbage carrier. And whenever the dustbin has filled, automatically you can send the information. This fellow will come and it will take, and your street will become clean. So even we can also do monitor our cows, how the cow is moving and what kind of behavior it is doing, and how its health is having. So those things also we can put sensors in the ears or any other part of the body, and we can monitor the health parameters, and we can save, we can track the cows. So these are all various smart home, endless applications, energy saving, security, hassle-free lifestyle and entertainment, elderly monitoring system. Many things are available. So that is the another application. So the smart grid and energy of internet is the another revolution nowadays is going to have in cities. Many cities already smart meters are fitted. In future we are going to have a on-demand electricity from various sources. Maybe it can be from your solar, or it can be from thermal, or it can be from wind. So varieties of energy generators are mixed, and depending upon the availability, price may also be vary depending upon your demand they are able to provide. So there is no power cut even in the summer, but maybe your unit price may increase like anything. But in the winter, your unit price may decrease, but plenty of because plenty of power is available. So those applications also you can generate. This is how we can combine various sources of energy generators through this IoT. So there are many applications. As I told you, it takes a lot of time, including agriculture also we can make it. We can monitor the soil quality and health based on the crop. We can change the fertilizer given as an input. We can also implement drone based analysis to analyze the crop disease. So we can also have water management. So all these things can be done using the IoT. So how, in more detail, if you see precision agriculture techniques we can use. So these are all the many applications are there. I like to introduce this structural health monitoring. You can avoid accidents like this using IoT technology. So even fire accidents also can be avoided. So see, these are all various applications. So we can monitor all our bridges sitting at one place, and it can be taken care. You can monitor various bridges sitting at one place, and you can avoid even the breakdown of the various structures, particularly bridges. So this is how we can monitor. Siri has done this. So I'm skipping. See, whenever we talk about the communication aspect, we need to understand certain standards. So these standards are, available with the devices. In Raspberry Pi 3, you have a Wi-Fi as well as Zigbee, sorry, Bluetooth. And in Raspberry Pi 4, you are having mesh-based Bluetooth also. So though, apart from these are all the devices which are connected from the Texas Instruments. Generally, for you, this is a very high level, but you need to understand various standards which are available, particularly 6-LoWPAN and Bluetooth and dual mode Bluetooth and particularly multi-standard. Like in one single chip, we can also provide Bluetooth, Wi-Fi, and Bluetooth, Zigbee, and Wi-Fi. So these are all the combinations that are coming. If it is possible, you can take it. But for you, this is higher side. But you can take Arduino and Raspberry Pi 2, 3, 4 boards. So these are all the various software tools that are required to work with the boards. Even these are all at a high level. For you, Sketch is more than sufficient if you are using Arduino, and a simple environment, Raspberry Pi operating system and its tool is sufficient for making the systems whenever we are trying to use Raspberry Pi 3 based. These are all advanced tools which are needs to understand more technically. I would like to say a few things about the criticism and controversies of the IoT. Though IoT technology is beautiful and fantastic and everything, there are problems, as I told you. What they have done, they always try to see, okay, privacy is the issue, and security is the another issue, and autonomy and control. Somebody is controlling, like Robo 2 problem. Robo 2 is solving the problem. Robo 1 was created the problem. So hence, Robo were banned, but ultimately we have taken Robo to help only in, to solve some other problem. So this way, many places we can have autonomous. We can give the touch feeling and everything. We have to have a controlled environment. If we are not able to provide the controlled environment, maybe it will reach to the uncontrolled environment and it will make your environment even more damaged. That's the problem. What we see. Simple example is Robo 2 and Robo 1. And social control is the another one. People will come to know whatever you are doing, each and everything, because you are connected to the device. And okay, political manipulation is there. Since you are connected to the device, and politically whatever they are doing and whatever negative things they can hide by making false development, and simply they try to influence the people the way the present politics are going on. So WhatsApp and other things are really making the polluted air. So IoT technology is also one of the tool to do that kind of thing. Every time you please think on it, the bad thing will spread more, and good thing will be you need to put a lot of pressure to spread it. So politically, if you see, many things are involved. So we cannot say which one is good and which one is not good. But this is one of the technology which will spread the manipulations. So the design and environmental impact and the influence human moral values. So those things are also involved, and we need to take care how to be with that. So now, as I told you, I'll ask a few questions. See, first of all, we need to see what is my application. You need to focus on it. Once you make what is my application, once you have decided which application you want to make the IoT technology enable, then you need to see what are the services that I need to provide. See, simply taking the sensor data is not sufficient. That sensors data has to be converted into the serviceable value. For example, let us say I want to know what is the temperature at Chandigarh in December 3rd week. Then your IoT enabled system should be able to give me, it varies from 35 to 40 degrees. So you required a sweater, 15 degrees to let us say 10 degrees. You required sweaters and other things. So this is service. A person who wants to visit as a tourist or as a shifting employee, he can prepare what is required. So now, if you give me the temperature profile, I may not be able to say anything. But if you give me, if you give me the temperature value, I may not be able to do anything. But if you give me the temperature profile, then it will be useful for service. Similarly, I am monitoring my, let us say, home appliance, and my refrigerator is working fine. And whenever something goes wrong, then my refrigerator should give me an alert, either to my phone or to my supplier or to my vendor. Then it is a service. Otherwise, if you simply send the sensor data, that may not be helpful. So now you have to make a question: what are the services that I have to provide? Then, if you say one home appliance like temperature monitoring, and then you need to see what are the sensors that are required, and temperature sensor is required, and what is the range of the temperature that I need to monitor. This is the critical part. So you need to put the questions like this, and then answer yourself, and then take what is the board I am having to implement, what is the processor I am having. Let us say Raspberry Pi 4, Raspberry Pi 3, or Arduino, or Arduino Max. So those boards, maybe you can choose, and whether that board is having all the connectivity to the input and all the connectivity to the output to make a actuator enabled. अगर ऐसा क्वेश्चंस लेके अगर हम
Sir, I'm
but I'm coming.
Time, sir. Because
okay,
another speaker, next speaker is waiting, sir.
Okay, thank you.
Thank you very much, sir, for setting up the stage for the next 3 days of the training program. You very well taught us about the basics of the IoT, the applications in healthcare, agriculture, and education, and particularly the structural health monitoring also. You talked about the protocols for communication between the devices. Yes, one should know beforehand while developing any application, any device. The person should know the protocols, the application, the basics of the thing. So you very aptly said that your innovation starts with the with the application in your mind and the services it has to offer. With that, thank you very much, sir. And we are open to the questions. There's a question in the chat. Sir, how do we detect the disease using sensor? I believe I can also add something on it before handing over to you. You might have heard of sleep apnea or the gout issues. We can use sensors in monitoring the sleep patterns for judging whether you are having some issues with your health, particularly your sleeping pattern, or we can use the camera or the sensor for monitoring your walking patterns, for observing whether you have gout or arthritis problem or not, or you might have seen ECGs and IR thermometers. They all are sensor based. So I tried to answer it a bit, but over to you to answer it more. How do we?
That's correct. See, one thing is first what disease you want to make it. So, if you want to analyze the disease, what disease? For example, cancer. For the cancer, you need to analyze the complete body, and you need to take MRI scanners, and you need to take the person behavior. So you can take the scanner report and do image processing, and then make it connect to the your device, so automatically it will make it. For example, let us say one person is not having outside, but can sometimes blood reports are required. So the frequent blood sensing, if you put a sensor in the wristwatch, and if you monitor the behavior of the blood pressure and other things through the help of the scanner report, automatically you can do the analysis. One best example is the cancer gives you the different shapes in your body. It makes kind of separate indication. So you have to do image processing to catch that particular change in the body. If you do that way, we can make it disease finding in this one. There are sensors. Any other question?
No as such, but yes, I request if there is a question with the teachers or anybody wants to get more on this thing, can always contact Dr. Kota Solomon Raju in NAL. And sir, with your permission, can we drop your email ID in the chat? So if somebody wants to connect with you, they can contact you on your email IDs.
Yeah. Already, I have already. You have. Okay. Right. I'm doing.
For the benefit of all. So if any of our attendees have any question in future, or anyone wants to collaborate with you, you can contact on the provided email ID. With that, sir, thank you very much for joining, for delivering the very first lecture and setting up the stage so that everybody can acquainted of the basics and the fundamentals of the IoT and the embedded system. Thank you very much, sir.
Okay, thank you.
Yeah. So
can
now
I leave?
So you can stay.
No. Now I'm leaving. I have some other work. Okay. Thank you
very much, sir. Thank you. So now we are moving to our next speaker. Before that, there's a question that, sir, which platform can be used for free IoT? So there are many free IoT platforms that will be discussed today. Our next speaker will be discussing those things only, how you can use the freely available tools for developing IoT prototypes. Dr. Ninad will be talking on that only. So our next speaker is Dr. Ninad. Dr. Ninad Dilip Behan Dale is an associate professor in the electronics department at KG Samaya College of Engineering. Dr. Ninad is postgraduate from KIT Germany. So prior to joining KG Samaya College, he worked as a scientist with Institute of Microstructure Technology at Karlsruhe Technology of Institute of Technology Germany for 1 year. Dr. Ninad holds PhD degree in microfabrication and image processing from the Indian Institute of Technology, Bombay. He was the gold medalist during his MTech at NMI-MS University. He also worked as a faculty in engineering institutions. Dr. Ninad is a founder and chief researcher at Ninad's research lab at Thane. So the attendees who are from Maharashtra can see how you can leverage the lab or the lab of Dr. Ninad and how they can be benefited and how their ATL lab can be benefited. With that, I request Dr. Ninad to take over the stage. Thank you very much, Dr. Ninad, for joining. Yeah.
Sharma for the kind introduction. I hope am I audible, and I will share my screen, and without further delay, I don't know, is there some screen sharing?
So you use the arrow next to your microphone icon. There is a icon upside arrow. You can click that and then you can choose the window. The window.
Yeah, I shared the full screen. I just wanted to check whether the highlighter is working. Is it working?
Yeah, highlight is working in your email. Yes.
Okay, thank you. Start use a freely available software, like the question was asked on it. It's Arduino Ide with another freely available tool called Tinkercad. So today's entire talk is focused on that. Those who are bored for them, let me just tell you, I don't have much of slides, but yeah, only 16 or 19 slides. And then I will be showing you some hands-on demo. If you have time, you can practice it with me, or later on. I would request host to record this lecture and share it with the students later on. So let us start with the talk. Let me just go full screen now. So what is the Arduino platform? So basically Arduino is a freely available tool. Mostly it's a hardware. Now how this Arduino relates to the IoT via a board called Esp or Node MCU. So these are the boards which are compatible to the Arduino. Now by default, Arduino board was a microcontroller board designed to simplify the life of a computer programmer. Because getting an electronic board solder and making a embedded system out of it was really tough for all the computer IT programmers. So to simplify their life, this Arduino open source platform microcontroller board was developed. The board itself is consisting of a microcontroller called Atmega 328. For those who are very new to the world of microcontroller, for them, I will just tell you that microcontroller Atmega 328 is basically a chip that can do some operation like turning on the LED, turning off the LED based on some input, like let's say temperature is crossing 30 or 20, etc. So in a simple word, this is a controller. The name micro comes from the word what you can say, the operation scale at which it works. So along with the Arduino hardware, there is a USB connector given so that there is no need for a programmer to program this microcontroller. So this is called in-system programming. That is, you connect this Arduino board to the system and then you can upload the code. We also have a reset button. So many of the people might have seen this Arduino board, and most of the pins are already mentioned on the board itself, so you don't have to remember them. Vin, then there are two ground pins. So this portion of the board, I think there are dual screens, so I don't know which screen is getting shared. I will just disconnect the other monitor and reshare the window with you. Okay, I think now we are on the same page. So here I can show you this particular section is a power supply section where we have VIN pin where you can apply anything between 6 volt to 20 volts. Then we have two ground pins, one for the VIN which is just next to it, and the other ground pin for the +5 volt to give it to the external peripheral devices. Then we have 3.3 volt, which is a new era of devices. So typically when we studied engineering, 5 volt was the standard VCC. Nowadays, after 2015, 3.3 volt is kind of a standard VCC, and nowadays no one works with 5 volt devices. The main reason being the power it saves. So generally all 3.3 volt devices are low powered. Then we have a reset pin, and then two extra pins in the new Arduino board, which were introduced, and those we will discuss later. Then we have 6 analog inputs. Now these are the pins where you can connect a direct sensor. So what is a sensor? I will just give you one brief example. So sensor you can consider as a thermistor which changes its resistance with respect to the temperature. So let it be a thermistor. And signal conditioning circuit for this, generally those who have studied the BEE subject, they might remember this is a voltage divider, and I am just using one more resistor along with my thermistor, that is called R2. And typically you just do this, and then your output voltage will be proportional to the temperature. Now the current flowing through this circuit I will be given by VCC, which is 5 volt typically, and divided by R1 plus R2 because those two are in series. And then the voltage across R1 is R1 into I. So I can just replace the I with the value that we have just found out. So I can just write R1 upon R1 plus R2 times VCC is the output voltage. Now, why I discuss this particular circuit, we'll later see when I discuss about Tinkercad. But just remember that these analog inputs mentioned over here, which are somewhere here, these are used for the taking analog input from the sensors like temperature, which I mentioned right now. Then there are LDR, there are many resistive sensors, even flex bending sensor, and any sensor that you have that changes a resistance as per the physical quantity, you can connect to these pins via a simple circuit that I have shown you. Then we have Icsp connector. So by default, your Arduino microcontroller, it's like getting a laptop, okay, but you don't have a Windows on it. So whenever you get a new Atmega 328 IC, it is not loaded with Arduino Uno bootloader program. So Arduino Uno bootloader is something that you can say it's like a Windows version for the microcontroller Atmega. And then we have Icsp, where the first program is to be burned from. So first time, even if you have Arduino, until and unless it is not purchased directly from the market and you are getting a separate IC, you need to use this connector. If you are getting direct 306 or 600 rupees Arduino, it's already burnt with Arduino bootloader. So you don't have to do anything in that case. These pins are only for those who are Mega 328 IC directly and want to use Arduino Uno as a programmer. For them, this is an important connector. Then we have a small SMD type LED, which is what I can say here or here. It's a power on indicator. So if this LED turns on, you're good to go. And then we have TXD, RXD over here, and those two LEDs allows us to understand that whether the PC is able to communicate with our microcontroller. And then we have your generally USB to serial communication IC. Now, if it is the original Arduino board, they will have Atmega 16U, which acts as a USB to serial communicator. But otherwise, you will have CC or CP ICs or FT232 ICs. So whichever is the IC that you see over here, accordingly you have to install the drivers for that particular board. So there are many fake copies of Arduinos available. Original Arduino will cost you around 900 to 1300 rupees. Arduino version 3. And if it is a fake copy, then you will get it for roughly 200 rupees also. So it depends on what kind of board you are getting. For me, it's absolutely fine to purchase a Chinese clone of this board as long as the work, because we just generally want logic 0 or logic 1 to be sent. Then reset button is there. This reset button allows you to reset the microcontroller. Then type B connector for programming. This is the same cable that you use to connect your printer. Then you have DC jack. This particular jack is provide Arduino the power it requires. Otherwise, if you directly connect it via USB, that also can power the microcontroller. And then you have different digital IOs. So digital IOs is something on which you can connect digital input or output devices. And then you have serial communication, which is the same communication that happens to USB. We will talk about that later. Then we have two I2C pins nowadays with new versions. Otherwise, we used to connect them at A4 and A5 pins. So this is the hardware of Arduino, which is not the focus of the talk, but people should know about this board because this is what we start with. Practically, Arduino Uno is not a microcontroller that has a IoT. So those who want to actually familiar with Arduino, they can look for this Arduino D1, which is the variant of Arduino which has a Wi-Fi and other facilities. So it is VMOS Arduino ESP8266 D1. This board will cost you around 300 rupees, and you can see it has exact similar pinout that I explained like with Arduino. Only difference is it has a micro USB port instead of USB B type port. And obviously it has only one analog input. So all the IoT devices in the market currently are having only one input, unlike your traditional Arduino board. There is another way to make Arduino as a, it's called ESP8266. So you can directly look for this ESP8266 board. So this is a very simple device you can see over here in the picture. So let me just show it. So this is the chip that you get that converts your regular Arduino into a Wi-Fi compatible, send the data over a Wi-Fi, and then it becomes your IoT device. So when people talk about Arduino and they talk about IoT, this is what they are referring to. Now let us go to the actual topic, Arduino Ide, Integrated Development Environment, IDE's full form. And here I am showing some older picture of Arduino Ide, but when we start with the actual coding, I will show you the real version. So this is 1.0.5. Currently, I guess 1.9.0 is the latest version. By the time I'm speaking, they might have released few more versions. Then this is a toolbar. More or less, even from first version of Arduino till today, this toolbar is having the similar buttons. First one is compile. So here, if you see this particular tick over here, the first button is the compile, which checks your C program. Now, the best part of Arduino, it directly works with embedded C. So those who are familiar with C programming, for them, there is no new language to learn. And all the microcontrollers that are compatible with this Arduino software. Originally, this Arduino Ide software was written for the Arduino board that I just shown you in the slide 1. But now all the newer microcontroller boards are supporting Arduino. That means those who already have familiarity with Arduino can directly use this IDE and burn their code. So they have to write an interpreter in between that converts this C program into a hexadecimal code. Then we have a programming area. So I will talk about this programming area and we will write some code during this session. And here you write that code. Then we have a serial monitor where you can see the outputs. Next thing is this particular push button. It is like upload button. So here it compiles and uploads the code to the microcontroller. So this is the second button, is the most important button that we have on a Arduino. Then we have new file, save file, open file, etc. And then some status message at the bottom. So once you see done uploading, then your code got uploaded properly. If you see some error, then you can check that error message in this Arduino Ide. Then a message from the system. So Arduino do debug the problem and gives you the information. Based on that, you can correct the code. Another important thing is here Arduino Uno connected on COM port 9. So this is very important and I will show you exactly how it is done. So I will just start Arduino Ide. Now, those who are very new, for them, I just show you how to get this Arduino Ide from Google. You can just type Arduino. Now there are two versions, Arduino Online, which I absolutely not recommend. You can directly download 225 MB Arduino. So you just search Google Arduino and then you click on the software. and then that's it. You should reach the download page of Arduino. Now, depending upon which version of operating system you have, like Windows 7 or Windows zip file. Now, zip file is for those who don't have admin rights. So if you are just a user in your college and your admin has not allowed you to install any program, still you can run Arduino by downloading this zip file. This is for non-admin users. Then Windows app like Windows 10, 8.1 can get a Windows app of Arduino. The first one is preferred. Windows app and zip file is not. Then if you have Linux 64-bit or 32-bit or ARM versions of 32 and 64 bits, you can download Arduino for them over here. And if you are rich, I don't think you will be working with Arduinos, but if you have MacBook OS above, then you can have a version of Arduino from this particular. So let us go back to the software. So once you download this 225 MB setup, then once you open, you should get some window like this. It might show you something like very bare minimum code. Okay, so this is the first program that you will see onto your Arduino IDE. To start the things with, the program looks a bit confusing. It has two loops already defined. So first one is Arduino Setup. Setup is a part of the program that runs only once. So whatever commands you want to run into your controller, setup is the place where you have to write it, and they will run only once. And loop. So real-time systems always run with loop. They never hit the end button. So that's why you have this second loop. So your program flow goes like this. I will just show it to you on a drawing. So I hope we will remember this circuit. I just get rid of it. So a program will go to the start loop or start setup, and then it will continue to remain in the loop. Okay, so this is loop, and it will never go to the end. The only way to end is power down the Arduino, or you can restart it. But even if you restart, it will go through the setup loop and it will come back and lock into the loop. So the only way to turn off the Arduino is not to write anything into the loop, or just turn off the button power supply, and then your Arduino program will end over there. So even if you leave your loop empty, it will be still running the empty commands, but it will not stop. So that way it's not good to leave it empty. And why you are building this system? To do something, so it should be on. That's why a loop program is very important. So let us understand the coding of this. Before that, let us go back to the presentation. I think we're talking about Arduino IDE. Now, since this COVID, everybody is working online. People have started using this particular software, very, very important software and free piece of software provided by Autodesk. It's called Tinkercad. Now it's not Tinker, it's Tinker. So it's basically tinkering with the circuits. So Tinkercad, initially they have started this Tinkercad for the mechanical engineers, those who are not very familiar with AutoCAD or SolidWorks. For them, making a 3D models or designing them was very difficult task. So Tinkercad was initially started with this idea that mechanical engineers' life become easier, but later on they simplified the life of a computer and electronics engineer by introducing Tinkercad for the circuits. So the same board which I have shown you, Arduino Uno, can be seen over here as a simulating tool, and then we have some breadboard, LED, and so this is the first thing that we are going to learn today, blinking the LED on a Tinkercad. So without wasting much time, let us start with that. I hope you have downloaded the Arduino software. If not, that is okay. So with Tinkercad, you have to create login first time. Now, since I'm using this for many years, I might have a login over here. I just have to check whether, yeah. So this is how it looks like when you start. You can click on sign in, and then you can use any of your educator's account, or if you are a student, and just click on join Tinkercad if you don't have. So I will just try to log in with my Google account. Now first time it will ask you some questions and just say, yeah, you agree with them, and you should land on this particular page. So it starts with 3D designs. So if you look at this particular point over here, it starts with 3D design, but next thing is circuits. So today we are going to focus on circuits. It also has code blocks. Now many of you might have seen this advertisement of Whitehead Junior, where a 6th standard kid write a program, makes an app and says this is what he can do. But that is not the actual programming. They are using something like code blocks. So code blocks are currently the highest level programming language. It not even use a English like statements. It just use the blocks and you just have to connect them like Lego. Even they don't fit together if they are not logically correct. So that way it becomes very easy. You just have to think about what lock to be used, what block to be used, and just put it in the correct position. So I will also briefly touch you on a code blocks. If you are using IoT devices, then Tune IoT is the right place to go for. This is a free code block type coding. So those who are not from any coding background, but they know logic is correct, they should go for this particular website. It's called Tune IoT for ESP8266. There are many other Tune IoTs available, but it is started with IoT programming. Everybody was afraid of IoT programming when it started, and that's where they use this particular website. So what happens is you go to this IoT block. Let's say I want to start an access point. So I will just drag a block and put it to this setup. Okay. And I will name my access point as Ninar. Okay. So it's done. Means your IoT is ready to start with a program, and it's all commands will go. Then let's say you want to create a server. You can just start a server at port 80. So it is so simple. Let's say you want the data to just drag drop the things and it will happen automatically. So you can just choose different strings or variables or whatever you want from this block. Again, these API keys and all we may not able to cover today, but basically those who have any idea about what I'm talking about, ThinkSpeak, they can relate to this well. Again, you can just duplicate the block and then put it. And if you think this is not making any sense, you can just pick the block and put it in a dustbin. So it's gone. And now once you do all these block connections, you just have to click on code and your C program is ready. So you can just copy this code and paste it into your Arduino Ide, which I think somewhere here. Just paste it over here and you are ready to go. So just upload. This is how easy it is. Again, those who are very new with Arduino, they must know these two things. Especially if you are working with IoTs, most of the boards that you get are ESP8266 or ESP32 compatible. ESP8266 is older, 2.4 gigahertz Wi-Fi, whereas ESP32 is a newer version which also has integrated Bluetooth. And for both the boards, you have to go to the file. Then you have to come to this preferences and you have to copy paste the what you can say links. So I just give them in your chat box so that you can refer to them later on. And yeah, you have to paste these two links, click OK, and then you come to the tool. Then you come to the board, click on board manager and you look for the board that you are looking for. So if you directly come to the board tools and go into the boards, it is difficult for you to find the boards. Again, by default, you will have only Arduino boards available. Since mine is a evolved version, you can see so many boards. So by default, you will only see Arduino EVR boards. In that only these many boards will be available. But as you paste these two lines into the preferences and restart the software, you can install the boards that you need. Let us say you buy a new Arduino Uno, you have to click on this, select whatever board you have. So I have Arduino Uno with me, then select that, then go to the tools. Now, since I have not connected any Arduino Uno onto the PC or its drivers are not installed, this port over here, I don't know whether you can see this, it is basically disabled. So I will just show you. This particular board will become enabled as soon as I connect any Arduino board to it. And then we also, once you do that, you can upload the code. If you buy any sensor and you don't know where to download its library file, how to install it in Arduino, there is a easier way. Go to the sketch option over here and then go to the manage libraries and type the sensor name that you have with you. So let us say I have thermistor or maybe DHT11 sensor. Just type that and search, and it should give you the latest libraries which are available by multiple companies on that particular sensor. Based on the sensor, either all of these libraries will work or only some of them will work. You can try them out, and if you don't find them useful, you can also uninstall them. So there is clear way of installing a library, and if it is already installed, it will show installed somewhere here. You can see it's showing installed, and then you can click on this library. If you see it is not working, you can just select that particular version and uninstall also. The easier way is to go to that library folder and delete everything if you don't find it useful. Once you install the library, it will start appearing into the examples, and here you will see those at the end. You will have those new libraries like DF robot DHT11 or whatever sensor library. These are your personal libraries and may not available. So that's why the name is given examples from custom library. So if you call your friend and ask him go to this particular Arduino library into this, he might not able to see it. So it's very important that you first tell him to install this library through Sketch and then go to the something called as manage library. So now let us go back to the website Tinkercad. So this is where we start. First program, as I mentioned, we are going to blink the LED. So what do we mean by blinking of LED is this thing. So LED will be turned off for half of a time and then it will be turned on for the remaining half cycle. So first thing, you click on create new circuit. It will take some time. Hopefully it will work.
Dr. Nirad,
Yes. Am I running out of time?
No. You can take as much time you want. We can stay by lunch also.
Nice.
But few of the attendees are saying that Dr. Nirad is going slightly faster than what they could.
Okay, I should reduce the speed.
Yeah. But
no
let me announce that Dr. Ninad will be with us for tomorrow also. So please practice at home, and if you have any queries, come tomorrow with the your hands-on query so that you can ask Dr. Ninad your questions. So stay calm. It's okay. He'll be around tomorrow also.
Yeah, and one more thing, whatever part I have just explained till this point was more like a theory that you can listen every day. So that's why we were running, because I want to cover more time onto the simulation itself so that you learn it properly. So you can forget till this point and just remember from this particular point how to start with the simulation. So let us start with the simulation. First thing, for LED blinking with a microcontroller, first you choose a microcontroller. I will choose Arduino Uno board. I just place it. Okay. Now those who are familiar with the LED, it's a light emitting device, and once you apply a proper voltage to this device, it should glow. Now in this simulator, you can pass a heavy current and still it will glow, but practically you never connect a LED without a resistor until and unless it is 1.2 volt supply. So typical value of resistor that you should connect with the LED is in ohms, and the value ranges from 150 ohm to you can go up to 1000 ohm. So I keep it to 20 ohms and then I connect it to one of the terminals. So LED will have a cathode and a anode terminal. So you can connect to any of those because they are in series. So anyways, they are going to limit the current. So I have connected to what we can say anode terminal. Next thing is I have a ground terminal over here. So what I will do is ground should connect to cathode. So let me just show you the connection diagram. So what we are trying to do is we are going to connect a LED. Then we have connected a resistor. The one end of the LED goes to the ground. The second end should go to the microcontroller. And whenever this microcontroller sends a logic high signal, the LED should glow. And whenever we send a logic 0 signal, the LED should get turned off. And this particular value is 220 ohms. So let us connect this ground. Any of the two grounds you can use. So let me just use one of the grounds. And it should connect to the cathode. So I will just select a point on which I can connect to the cathode. Next stuff is VCC. So as I mentioned, I should connect it to one of the microcontroller pins. But beforehand, let us see whether this particular LED is working or not by connecting it to the fixed 5 volt supply. Now just for your visibility, I make the VCC as red wire and the ground as a black wire. Okay, so I have just connected a LED and by default this LED is off, and if I run the simulation, the LED should get turned on. You can see the LED is glowing now, and as soon as I stop the simulation, the LED should go off. Okay, so now let us try and blink this LED. Now LED blinking is a hello world for any electronic circuit. So if you can blink a LED with your whatever circuit you have with programming, you have a full command over that particular electronic module. So I just connect it to one of the pins. Currently this is the second pin that I have connected it to. So this is for simplicity, let me just change the color of this wire. Next is if I run the simulation again, I don't know what is the status of pin 2, but it can be logic high or logic low. Based on that, the LED will turn on or turn off. Now you can see the LED is not glowing. Even the power LED is on. So that means the resistor that I have connected is connected to logic 0 of D2 pin. Now Arduino do have pins from 0 to 13. That means total 14 pins are there. And now we have to write a program for this. So before writing a program, you ensure that you stop the simulation, go to the code. Okay, so this is again, firstly, Tinkercad is compatible with block codes. So they have written set the built-in LED to high, then wait for 1 second, set the built-in LED to low and wait for 1 second. So this is the by default program if you load Arduino board, and particular code, very similar code is required, but instead of saying set the built-in LED to high, I need to set pin 2 to high. So I can just connect it. Okay, then again on pin 2 I have to set the thing to low. So I can change this to pin 2 to be low and then wait for 1 second. So here you can see that it's very easy to do the programming with the help of block codes. Again, I have to move this particular part. I just disintegrate it. So I have set pin number 2 to high and then set 2 to high again. So I have to change it, this one to low. So I have set pin 2 to high, wait for 1 second, then set pin 2 to low, wait for 1 second. So with that you can have different inputs, outputs, comments, controls, maths and variables. So these are the things that you can have with block codes. I personally like C programming, but there is an option where block codes and C codes can be seen simultaneously. So if you want to add a wait loop, you can see how it does change your C program. It automatically adds the C program. Let's say I want to wait for 3 seconds. So it automatically updates the program also. And we will discuss this program also in detail. I just delete this also. So we are ready with our blinking code, and if you don't want to keep working with block codes, you can directly go to the C program also. It will ask that if you go to the C program, it will destroy all the block coding facilities. You can just click continue. And now we are into the C programming code. So the first line is void setup. Setup is a part of the program that only runs once. Then pin mode 2 set to the output. So this is where I have connected my LED. So it's a digital IO pin. So I need to either set each pin into input or output, and that declaration has to done only once. So that's why it is in the setup part of the loop. Then void loop, digital write pin 2 to high, wait for, now this delay is in millisecond. That's why wait for 1 second is represented by 1000, because 1000 milliseconds is equivalent to 1 second. And then digital write pin 2 to low, wait for 1000 again. Let us go back to the Arduino Ide, and those who don't have any idea about where to get these codes, it's generally in the example, the basic, and the blink code is also available over here. So same code available with Arduino, and there are some initial comments which you can read. Here what we have done is we have connected pin 2, so that's why pin 2. Later on you can make it pin 4 also. Then wherever you see the digital write, so this is not a standard C program. Pin mode is embedded C command which converts each pin as output or a input mode. Digital write is again not a standard command in C, but one can understand that this digital write, that means you can write it on a digital value on some pin. That pin is currently, I think it's 4. Then delay, let's say I want to reduce the delay to 500. I just change that. Again, digital write pin 4 to low, and then I can for okay. I got a question saying why use wait between the two steps. See, if you know anything about human eye, if we do a blinking very fast, then what happens is within 1/10 of second something happens due to the persistence of vision, we cannot see it. So if I turn off the LED, this Arduino works at a speed of 16 megahertz. So 1 upon 16 megahertz will be in some microseconds, 1 upon 16 microseconds, which is very difficult for me to see. It's impossible actually. And that's why we have to, whenever we have anything related to light, we have to wait in between before we do any modification. Okay. Next thing is you just start the simulation, and I hope it will blink the LED. So you can see this particular program that we have written can blink the LED. Now you say ki let us speed this up. So instead of 1000, I will just put 300, and this could be your homework. You find at what bare minimum delay you can still see the blinking. It will vary from person to person, so that's why again, while running you cannot change the code. So first thing, you have to stop the simulation and then only you can change the code. So I just write 300, 300, and now let us run the simulation again. I think there is some mistake in the code. Okay. And now if you see, the blinking speed has increased. So I hope the LED blink example is clear, and screen is not visible. Oh, sorry. Is it now visible?
It's visible.
Okay.
There must be some network issue at some end, but otherwise it's visible.
Okay. So I hope everybody has understood. For your ease, I will just give you this code, and you can try it at your home. Tomorrow you can tell me what is the minimum delay that you can have before you see the LED blinking. Again, that will tell you how fast your neuron works. So it will vary from person to person. Let us go ahead and let us try and do some sensor interfacing. So I don't know what is the temperature over there, but let us try and build some temperature controlled system. So let me just delete everything. Hope you remember the first thing that I have told you, how to connect the sensor. So let me see whether I have a thermistor here. So here in the search you can type temp. Okay, so we have a temperature sensor directly, TMP36. Now this particular 3-pin sensor comes with its direct Vout pin. So you just have 3 pins. It's LM35, TMP36, any of the sensor you can use. Its per degree variation is around 10 millivolts, and you can do one thing is connect this to the VCC line. So power pin is connected to VCC. For our simplicity, we will always follow the color code. So red is for VCC. The other pin was for the ground. Okay. So now I have connected 2 points. The V out should be connected to analog input pin. Again, just to maintain the color code, I can use some other color. Now, where to get a program for this? So before we build a temperature system, what I can say is how to read this temperature. So you go back to the Arduino Ide, go to the files, go to the examples, and in the basic, the first program is analog read serial. This reads the analog pin available onto the Arduino and gives its output in terms of the serial values between 0 to 1023. Why that particular value? Because it has 10-bit ADC, so 2 raised to 10 is 1024, but it starts with 0, so that's why 0 to 1023. Now, those who are very new to this, they might feel very difficult, so just forget about it, what I told just now. But those who have some idea may understand why it's 0 to 1023. So first thing in the programming, I generally clean up the program. I just remove all the initial comments. In the setup loop, the first thing is I want to see the analog value. So what I will do is serial communication at 9600 bits per second. So this is what is command. Again, you will say this is not a C programming. Yes, only thing you can see from C programming is this semicolon, the way these curly brackets are opening and closing, and this void stuff. Rest all is all embedded system C programming. So this serial.begun is not a standard C program command. 9600 is a baud rate. Typically 115200 is the new baud rate of today's eras. But if you are graduate like me in your 2000s, you might still be happy with this particular number. New thing is once you do this, your loop starts. Here we are continuously reading the temperature on that pin. So I need a variable. Again, this is first time we are seeing any C program where we declare int sensor value, and you generally do all the declarations in the beginning of the program. So you can just write int sensor value equal to 0. You will also see that these Arduino programmers are using something called as Camel Case. What is Camel Case? If I have Ninad 1, so Ninad is a separate word and 1 is a separate word, or Ninad is 1, whatever. So in Camel Case, what they do, they will write the first word as it is, but in Ninad and is, this space is removed. Instead of that, it capitalizes the next letter. So how the camel has the bump at the back, that way each time you remove the space you capitalize. Then for 1 also you capitalize O-N-E. So this is how the sentence is written, and you will see throughout the programming they will have this kind of weird looking English written, and that is what we call a camel case. So sensor value by default temperature value, we don't know anything about it, so you can initialize to anything. Then you just assign the same sensor value variable. Again, do not be afraid. If you want to change it to Ninad or any other variable name, do change it, no issues. Even if you don't follow the camel case rule, that is also fine, but don't give a space, because that is a C programming rule that your variable name cannot have a space. But you cannot change these functions which are in orange color. These are the standard C programming or Arduino C programming functions like analog read. Then you just serial println. So again, a standard orange color, don't change it. I want to print the value of Ninad. Here you can see that analog read, I have written some weird stuff A0, and if you remember the picture of Arduino, you can see this particular place there is A0 written and my connection goes to A0. So then you have a delay again, as I mentioned, you have to have some delay for your brain to process the value, and then you can close the loop which you have started, and that's the end of the program. So I have simplified the code for you. Let us put it into your simulator. So go to the code, remove the earlier code, paste this new code and start the simulation. So once your simulation starts running, on the circuit level you will see nothing, because all the readings are getting captured and sent to the serial port, and to monitor those values we need to turn on the serial monitor. So here in the bottom of the page you can see there is a serial monitor which you have to start, and here you can see the temperature readings are getting mapped to 153, and you can also check the current temperature by clicking on the sensor. It is showing 25 degrees is 153. Okay, now as I vary this temperature, you can see the value had changed. -40 is represented on the serial monitor as 20. So there is a definite need for calibration, and 125 is represented as 358. So this is the range of readings, and I would like you to try how to calibrate. So whenever I say 30, I should see 30 on my serial monitor, and for that you can I will just give you the hint how to do that. First you take multiple points, plot them for actual value, what is the corresponding temperature, and keep on plotting it. Once you get the complete plot, then try to do a fitting and then find something like y equal to mx plus c. Now most of the sensors are non-linear, so you can use a second order fitting also, but that is up to you. So I hope the temperature plot is pretty clear, but again reading the value is not a fun, so you can turn on the graph mode, And now here you can see how the temperature is increasing, and now it will start falling. You can keep it constant also in between. Again, if it increases. So our job should be to design it, let's say at 35 degrees, you turn on the AC. So this value is around 176, and if it is below, it is like below 176. So I have to write a simple code to turn on the LED. We already have written the code for turning on the LED, which is, I think, stored somewhere. So let us update this particular code. So here you can say if NINAD value has increased over 175, okay, then you have to write a code to turn on the LED. Else what you can do is else you turn off the LED. So these two blank loops are there, which we will use to turn on and turn off the LED. Okay. So now let us again go back to the first program where we have connected a LED to this Arduino. So I just stop the simulation, throw this code block inside, and first let us do the communication or the connection with the LED. So I just search for LED and just keep it next to the thing and a resistor. Again, as I told you, you have to change the value of resistor to, you can also change it to 0.33 kilo ohms, which is again 330 ohms. And last time I think I put 220. Anode, I can connect it to the LED's one terminal. Anode can be connected to a resistor, and cathode can be grounded. Just for ease of colors, I just make black for all grounds. And this particular thing, I think we will put it to some pin on Arduino. So let me put it to pin 2, which is our favorite. Okay, so now again for simplicity, I just choose other color. So this is the circuit. So now we know if temperature crosses 30-35 degrees, the LED, that means our cooler, will turn on, and otherwise it will turn off. A simple application and a code, a slight modification to the code is required. So I just wrote if NINAD greater than 125, I have to do something. So let us go back to the LED blink code. Here we have set pin mode. So I choose that and set it to pin mode 2 because that's where I have connected my LED, and then I will turn on the LED. So if it is greater than 175, we will turn on the LED. And if it is below 175, we will turn off the LED. For your understanding, I just copy paste this code into the chat box. Okay, you can refer it later also. And I will also paste this code to our course. Okay, and now let us start simulating. Okay, so I think there is some mistake in the code. Let me just check.
It should be low.
Sorry, I write LED. I just update the code on the program and let us start simulating. So by default the value is 153, and you can see the LED is off, and this value is 25 degree. So let's say temperature is increasing to 32, 34 and 35. Your cooler started and it will be turned on till your temperature comes down again. So again, if it goes high, it goes like that. So this is how you can design a control system. And then you can use ESP8266 and remotely control this thing, or there are many things you can do with this. But this is just a starting point and an introduction. I hope I have, okay, I've just finished 3 minutes late. So with that, we'll stop for today. And again, tomorrow we will meet for one more round of sessions. So if you have any doubts, you can ask. Okay, if there are no doubts, should we end the session?
I believe that was a really informative session, Dr. Nath. We also got to learn a lot of new things. I myself was following up your lecture very closely, and
Yeah.
yeah. So thank you. There was a somebody said that simulation part is understood, but facing difficulty in writing code. Actually, that's why we all are here. Like somebody said, I'm totally new to it. Exactly. That's why we are meeting, and that's we are putting our efforts for 3 days for learning new things. That's why. Our teachers are here, our experts are here. We are here. So please keep learning. Stay glued to your screen. Keep working with the expert. When the expert is telling you something, some hands-on, please do on your system. That's why we supplied you some prerequisites, some manuals for installing Arduino Ide at your machine, and how to make account at the Tinkercad. We already supplied their documents to you. So please follow with those documents, and so that you can, when you come tomorrow, you will be more informed of the the lectures and the hands-on. Yeah. Somebody have question? Can please type in. Dr. Ninad, somebody have asked, do we need to connect the board to our laptops?
And not in the simulator, but yes, practically it's better if you have a board, connect it and do it practically, but not in the simulator, not at all.
Okay. Thank you, Dr. Ninad, for taking your time out and explaining us the things. It was really great lecture. I thank you on behalf of organizing team and the attendees today. We have teachers, joining from all parts of India, from Kashmir to Kanyakumari, and from Rajasthan to extreme northeast Arunachal and Meghalaya. We have teachers from all around India. So thank you very much. I request teachers to not to log out. Just wait for a moment. We'll be putting a quiz link, so that you can evaluate yourself about your learning, and that would be learning and experimenting quiz, and definitely will be giving away some good prizes to the top 3 scorers. So that quiz link will be open for half an hour. So if there will be tie, we will be giving away the prize to the person who will be attending the quiz first. So please stay glued. We'll be putting that. Okay, the quiz link is already there in the chat. You can try the link and put your entries over there. Somebody asked, will it be possible to have a practical experience at Chandigarh? Yes, you can have, because tomorrow we'll be having speakers from CSIR Chandigarh. So we'll be putting their contact details for your help, so that you can reach out to them for your experimentation part, and you can collaborate with those speakers and experts. And yes, CSIR-IMTECH is always open for you. You can come to Sector 39, Chandigarh, and CSIR Institute of Microbial Technology, that's in Sector 39A. Yes, thank you. Thank you. We will be very much happy to help you out, sir. So quiz is open. I request all attendees to please participate in the quiz and win some awesome prizes. We'll be giving away prizes to top 3 scorers and a appreciation letter from us. Yes, in Delhi too, we have our labs in Delhi. National Physical Laboratory is there. We have experts over there. I can link some of the expert with you. Just drop me an email whenever you want. I will, link you with the experts over there. No problem. We are there to help you. No problem. We are more than 37 labs across India and like more like 20 centers in some cities. So you all have my email ID. You can write to me for any help you want. No, why link will be open at 1:40? Please open it right now. Acha, okay. Sorry, I'm sorry that link will be up to by 1:40 p.m. So you have exactly 31 minutes to attempt the quiz. Please do it and evaluate yourself how much you learned today. With that, we are signing off for the day, and tomorrow I request you all please join before 10 so that we can start exactly at 10. Today we started at by 10, late by 10 minutes. So tomorrow, please, all are requested to join before 10 so that we can start right at the time for the maximum learning. With that, thank you very much. नमस्कार आप सभी गुरुजनों को जो जुड़े हमारे साथ, आपका बहुत बहुत धन्यवाद। कल हम पुनः मिलेंगे आपसे नए स्पीकर्स के साथ, और ठीक है, जो आपकी क्वेरीज आ रही हैं कि आपको YouTube पे वीडियो चाहिए, हमने लिंक पोस्ट किया है चैट में। जैसे ही ये वर्कशॉप खत्म होती है, हम इसके एडिटेड जो वीडियोस होंगे उस YouTube, जो हमारा जिज्ञासा का YouTube चैनल है CSIR जिज्ञासा, उस पर ये वीडियोस अवेलेबल करा दिए जाएंगे जैसे ये वर्कशॉप खत्म होती है। PPTs भी हम स्पीकर से रिक्वेस्ट करेंगे कि हमें वो PPTs दे दें। आज वो नहीं हो पाया, लेकिन आज के इस चीज से सीखते हुए हम उनसे मांगेंगे और कोशिश करेंगे कि कल से वो आपको अवेलेबल रहें PPTs। धन्यवाद आप सभी का ज्वाइन करने के लिए। We are signing off for the day. We'll meet you tomorrow before 10. And thank you very much. Thank you very much for making the event successful. Thanks for your cooperation that you joined. Thank you very much. Thank you very much. I got a thought in my mind, so before I leave, I want to make it here. Please let us know if you have any specific requirements, particularly about the workshops. If you want to have workshop on some other subjects, some biomedical devices or something, some edutech technologies or agriculture technologies, please let us know. We will arrange for you. No problem. We will have those workshops for you, because we know that once we'll train the teachers, there will be big impact on our students. So please drop us a mail whenever you want to have a workshop on some particular domain. We'll have it for you. With that, I will not bug you more. Bye-bye.